You know, from the simple pencil and paper that sketched out the pyramids, all the way to the VR headsets designing the cities of tomorrow, the art of technical drawing has really been the silent architect of our entire world. But what happens when this ancient skill crashes head-on into the insane pace of modern technology? Well, that's what we're going to get into.
At its heart, you got to think of technical drawing as the universal language of making things. It's that silent, perfect conversation between a designer in Tokyo and a manufacturer in Berlin. It makes sure a really complex idea becomes a precise physical reality without a single word ever being spoken.
So how does this universal language actually work? I mean, what is it that makes it the absolute indispensable backbone of pretty much every technical field out there, from architecture to aerospace?
It is quite literally the blueprint of progress. Every single skyscraper that pierces the sky, every smartphone that's sitting in your pocket right now, it all started as a set of incredibly precise lines and symbols. Without this shared language, our most ambitious ideas, they just stay ideas.
Okay, so before we had pixels and processors, there was this simple, really powerful connection between the mind, the hand, and a piece of paper. This was where ideas first took physical form, in that kind of messy, intuitive dance of a pencil on a page. And this isn't just some misty-eyed nostalgia for the good old days. Neuroscience actually tells us that the physical act of drawing forges these incredibly powerful neural pathways in our brains. It's how we teach our minds to think in 3 dimensions, to mentally rotate and dissect, and just understand complex forms long before a single thing is ever built.
And this brings us to a really crucial distinction. See, hand drawing just thrives in that ideative stage. That's the wild, messy, what-if phase of creation. Computer-aided drawing, or CAD, on the other hand, absolutely excels in the executive stage, where precision is everything and every single millimeter counts. They're not competitors, they're partners in the same creative process.
So, what happened when that executive stage got a massive, massive upgrade? Well, the arrival of computers didn't just change the tools. It fundamentally shifted the entire paradigm of technical drawing.
I mean, the pace of this evolution is just staggering. We basically leaped from tools that Leonardo da Vinci would have recognized to walking through buildings in virtual reality before a single brick is even laid. This rapid acceleration brought immense power for sure, but it also came with a super steep learning curve.
And the challenge wasn't just, hey, learn this new software. No, it was a complete rewiring of how design information was handled. All of a sudden, a drawing wasn't just a static image anymore. It was a file, a dataset, a living document that could be shared and changed instantly. A whole generation of professionals and educators had to adapt, or honestly, get left behind. So, naturally, this digital tidal wave crashed right into the classroom. How do you teach a timeless skill like spatial reasoning when your tools are changing every single year? How do you balance the raw power of the human hand with the cold precision of the pixel?
And this right here is the core challenge: teaching spatial visualization. It's like a mental superpower. The ability to see a 3-dimensional object in a 2-dimensional drawing, to understand the hidden lines and the unseen faces. It's a skill that's easy to describe, but man, is it notoriously difficult to teach.
So, the big question is, how are educators tackling this in the digital age? And the answer isn't some single magic bullet solution. It's this fascinating explosion of creative, hybrid approaches. Yeah, forget one size fits all. The modern technical drawing classroom is this dynamic blend of old and new. We're talking smart rulers that talk to tablets, and get this, remote-controlled robotic arms that let students practice physical drafting from hundreds of miles away. It's all about a both-and approach, not an either-or one. So what we're seeing is a really targeted approach to teaching. You've got animated modules to break down complex ideas like orthogonal projection. Then you have project-based learning to give students real, hands-on experience with the tools. Each method is like a specialized instrument in the educator's toolkit, designed to hone a very specific skill.
All right, so if that's the present, what does the future of drawing even look like? Where are we going from here?
The future is intelligent. A drawing is no longer just a picture, it's a data-rich model that talks directly to 3D printers and construction robots. And VR isn't just for looking at things anymore. It's becoming the classroom itself, a totally immersive space to learn and create. And really, that's the bottom line. We're not just teaching students to draw lines anymore. We're preparing them to create the dynamic, intelligent models that are going to drive the industries of the future. And this all leads to a pretty fascinating question.
As our tools become smarter, maybe even smarter than us, what does it even mean to draw? As AI starts to anticipate our next move and VR builds entire worlds around us, the very definition of this ancient human act is being redrawn right before our eyes. What's it going to mean to create something in another 50 years? Makes you think, doesn't it?